Alright students, as promised, we're going to go over this worksheet. So number one, or in the example, we're given these points, we're to plot each ordered pair. So 3, -2 would be here, right here. So that's that point there. Okay. So we plotted that point. Now -1, 5, -1, 5, right here. 4, 0, so 4, 0, and -2, -4, right here. Now, as one of our colleagues in our class pointed out, it isn't clear to me what the structure of the line should be. Is it a shape? Like, look down here. So there are polygons, right? I don't know if this is supposed to be a polygon or a line. But since we don't have a key, let's assume it's a line. And, that could be wrong. But they didn't give me a key, so I don't know. This method of teaching you inverse equations is kind of silly to me, but I'm not in charge. I suppose it's beneficial to show you this. I have absolutely no idea what do I do now? Do I connect here to here or here to here? Right? I don't know. I don't have a clue. You know what? Before I make that mistake, let's go ahead and plot the domain. So the domain is clear. The domain refers to the x values. So that would be the minimum x value is -2. And they want us to use absolute value notation, which would be less than or equal to x, less than or equal to the maximum x value, which in this case is +4. Okay? And then the range is the y, or the f of x. And so the minimum value is -4. And that's less than or equal to y, or f of x, and the maximum value is 5. So less than or equal to 5. That's that's inequality notation. So now they want us to find the inverse of the ordered pairs using a different color. So we'll use blue. The way you do the inverse is you just switch -2, 3, 5, -1, 0, 4, and -4, -2. So we'll plot these points, and this is going to be our f inverse x, right? This is how you write that. F -1 in the exponent section x. So f inverse x, so -2, 3 would be here. 5, -1 would be here. 0, 4 would be here. -4, -2 would be here. So again, I'm completely lost. One thing we can do is, by the way, this data here goes right here. See, actually, I can be really fancy and just move it in OneNote. Just move it down here. All right, very fancy. All right, so, and that would be like the set. So I want to put that in set notation. So these are discrete points. Okay, now no clue how to connect it, but they want us to graph y equals x. So let's use a completely different color. We'll use this yellow color here to graph y equals x, and that's just a 45-degree angle. Get it to 45 degrees. Come on, right there. Okay. So passing through the origin, the parent function f of x equals x. Right there. Okay. So what they want you to notice is that this is y equals x. All right, so they want you to notice that the inverse is a reflection of the original across this graph. So let's write that down because that's kind of a central key point here. We'll say the inverse is always a reflection across f of x equals x, or y equals x. Okay, so I'm not gonna connect those points. I'm afraid of connecting them incorrectly, but that is the inverse. I just don't know how to connect them, so we won't connect them. Now the domain of the inverse is going to be the range of the original, and the range of the inverse will be the domain of the original. That should be obvious from how we just switched them. So the lowest value of the domain of the inverse in blue is going to be -4, less than or equal to x, less than or equal to 5. Okay, so that was the range, is now the domain of the inverse. So we should make a note that that's the same thing there, but we switched the y and the x. Okay, and now the range of the inverse should be the domain of the original. So let's check and make sure that that's true. The range, what is the lowest value of the range of the inverse? That would be -2, less than or equal to y, and it should be 4. Yep, top number is 4, less than or equal to 4. So again, notice that the domain of the original is the range of the inverse. Okay, so reflected across this graph. All right, moving on. What conclusion can you draw about comparing? Well, we already did it, so maybe I'll just move this down here. That's what I would put. All right, so now here's the homework part. Plot the ordered pairs, state the domain, determine the inverse, and state the domain and range. Okay, so plot the ordered pairs. I mean, this should be fairly easy. 0, -3. So 0 on the x, -3 on the y would be the y-intercept. And then 4, 1, 4, 1, -2, 2, 3, 2. Okay, so we just switch them. The inverse would be -3, oh, I see what they Don't want to split the domain there. So the this would be negative 3 comma 0, 1 comma 4, 2 comma negative 2, and then 2 comma 3. Okay, so let's go ahead and plot those. Negative 3 comma 0, 1 comma 4, 2 comma negative 2, and 2 comma 3. Really? Because that's not a function. See how the 2's repeat? Because we're going to switch the locations, so that would be 2 comma 3. So that's not a function anymore. Interesting. So I guess it didn't ask us if it's a function. So the domain of the original, the smallest red value is a negative 2 on the x, and less than or equal to x less than or equal to 4, and the range would be negative 3 all the way up to 2, so less than or equal to y less than or equal to 2. So now we'll jump to the inverse, which would be, the domain would be negative 3 less than or equal, I'm trying to combine set notation in. So negative 3 less than or equal to x less than or equal to 2, right? So it's the same as the range of the original as the domain of the inverse. You just swap the x and the y, and then the range is going to be negative 2 less than or equal to y less than or equal to, it should be 4, and it is 4. Okay. Alright, so let's blow through this one. 3 comma negative 3 right here, and 2 comma 0 right here, 1 comma negative 4 here, and negative 2 comma 2 here. Okay, so one thing I didn't do is plot that y equals x, so you can see the reflection. Let's always do that. And then we'll do the same thing over here. I don't know why it didn't. Why isn't it letting me coloring it in? I'll just make it bigger. There we go. When in doubt, just make it bigger. Okay, so here we go. Nice. All right, so now we'll plot the, well, first let's find the domain here. That's going to be negative 2 less than or equal to x less than or equal to 3. And the range is going to be negative 4 less than or equal to y less than or equal to 2. And so the inverse, now we'll go ahead and find the inverse. So you just switch them, negative 3, 3, 0, 2, negative 4, 1, 2, negative 2. So we'll plot those points, negative 3 comma 3 here, 0 comma 2 here, negative 4 comma 1 here, and then 2 comma negative 2 here. Okay, so it's saying that that's a reflection across y equals x. So, and remember, this is y equals x, y equals x. And so the domain of the inverse is the range of the original. So negative 4 less than or equal to x less than or equal to 2. Yep, that matches up there. And then the range should be the domain. That would be -2 less than or equal to y less than or equal to 3. Yep, 3. Okay. This is just silly to me. I don't like this at all. So basically what they want you to do is find what are called lattice points. So here's a point, here's a point, right? You could just plot all these points. You can make like a chart. You need lattice points. So those are points where the gray lines in the background are crossing. And so here's another one. You know, I don't know how much of this I want to do actually. And what's the inverse? So it's even hard to read. So this here is -6, 7. And then we'll just graph another couple of points. We'll do -2, 3, and then we'll do 5, 3, 6, or 0, 6. Sorry, 6, 0, and then 7, -3. Okay, so the inverse would just be the opposite, would be 7, -6, 3, -2, 3, 5, 0, 6, -3, 7, and we'll plot those points. So this is the original, and this is the inverse, okay? So we'll plot those inverse points since that's what they want. 7, -6 would be all the way over here, down here, right here. 3, -2 would be here. 3, 5 would be here. The x's repeat, so it's not a function, but that doesn't matter. 0, 6 is here, and -3, 7 is here. Okay. So I think we can connect the dots on that one, but first I want to go ahead and plot in this just to show. Oh look, it's not really 45 degrees, is it? Somebody didn't scale this properly. No surprise there. So there's the graph, and then what we're supposed to interpret is that this inverse is a reflection across the graph of y equals x. So can connect those dots there, and then connect these dots here, and then connect those dots there. Okay. And that's supposed to be a reflection across the x-axis, if I did that right. So they want the domain and range as an inequality. So the domain would be what? -3 less than or equal to x less than or equal to 7. And then the range would be -6 less than or equal to y less than or equal to 7. Is that right? Yeah? Okay. Yeah, I'm not going to do the rest of these. This is silly. Okay, I mean, that kind of gets you started. I hope that was helpful. Thanks.